Hello again, everybody. Welcome back to another fun physics lecture for some fabulous physics students. Uh, Here we are doing geometric optics some more. Today, we're going to talk about curved mirrors that curve the other way. They are convex mirrors. Okay? We're going to figure out how to make images with them. So the question is, how does that work? You look in a convex mirror and you see things. And the question is how do they make that? So remember, we have two kinds of curved mirrors, convex and concave. Last time we talked about the concave one. Remember, you can tell the difference. Think of a cave and you're shooting light into a cave. So that's a concave mirror. Kind of looks like a cave a little bit. Convex is the other one, curved the other way. So couple things. A convex mirror still has the same focal length, focal point, center of curvature, and radius of curvature. All right. And F is still R over 2. You'll also hear this called a spherical convex mirror. All right. So if you hear any of those words, you'll know what we're talking about. But look where the cat is now. The cat is on the other side of the mirror. So we have the focal length and the radius of curvature on one side, and we're looking at things on the other. Okay, so our eye is going to be over on the same side as the cat. So the question is, what the heck happens to those rays? All right, we see an image, but how does that work? Because the rays, for example, from the tail of the cat hit the mirror and fly off the other direction. Well, here's what it looks like. We have to trace those rays behind the mirror. And it turns out they're all going to go to one spot. And no matter where our eye is, or anyone else's eye, as long as we're looking at the mirror, it's going to be behind it. Often, we see the object and the image. Notice we can probably see some rays from the object itself. Imagine them going out from the tail of the cat straight into our eyes. All right, so this gets a little tricky, but basically we're going to use the same three rays we did before. All right, there they are, going through the focal point and the radius of curvature. Now notice something. One of the rays doesn't go through the focal point. It only kind of doesn't. And we'll talk about that in a minute, but this is a little trickier than the last one. So pay attention. Again, remember there's probably a lot of pausing and drawing and starting me up again. So feel free to do that. All right, so first of all, we're going to start with the ones that go through the focal point, these two. Okay, so I'm going to walk you through how to draw this. What I want you to do first is draw the mirror, focal point, the radius of curvature, and the cat or a tree or whatever else you're doing. And here's step one. Draw the straight ray and the ray that would go through the focal point, but only draw them until they hit the mirror. So what you do is you draw one straight and stop when it hits the mirror, and then lay your straight edge from the tip of your object at one point, and then lay it through the focal point at the other, but only draw a line up until you hit the mirror. Okay? So once you do that, then what I want you to do is stop and then take step two, which is project those lines back. So the one that you drew straight to hit the mirror, so I'll do this with green. So take this one that you drew and then put your straight edge at the focal point and where it hits the mirror and draw the reflected light going out. Okay? So then you draw this one. Okay? Then with the other one that you drew that would have tried to go through the focal point, draw it going straight out from the mirror. Okay? Once you've done that, step three is very important. Draw or extend the reflected rays back behind the mirror. Not the ones that hit the mirror to begin with, but the reflected ones. Draw reflected rays backwards until they meet. Once they meet, boom, that's where the tip of the cat is. Okay? Last one is the ray that goes through the radius of curvature. Draw that one, and it reflects back on itself. So you can just extend that one both directions through the radius and back, and voila, all three should meet at the same point. Okay? So, a little tricky, but hopefully you paused me and went through the steps. So, for today, how do you feel? We went through how a convex mirror makes an image. All right? Homework for today, 2 questions. So look at them, see if you can answer them. Stop me before you roll on to the answers and see if your answers match mine. All right? So go ahead and pause me, and when you're ready, start me up. All righty, and here are the answers. Enjoy. Have an awesome day. Good night.